Good afternoon. Can you hear me? Okay, let's start. Today, let's learn about the comment and variables, and also compliance and force control, Modbus TCP slave function, and pick and place. I will talk about how to create and how to handle variables. When using motion command previously, we saved the coordinate for each motion, but when you create and save variables, you can repeatedly open the value set for those variables. There are typically three types of variables: global, local, and system variables. You can create them in global variables, define, and system variable menu, respectively. To describe their characteristics, global variables is available throughout the whole program. The local variables are generated by a define command, and additional global declarations are required if they are not to be used while moving to sub and main sub. For system variables, you can share the values of variables between the tasks. Even after the program ends, the finally computed values remain. However, system variables is not stored in the task, unlike the previous two commands. Thus, a new addition is required to the controller that have been changed when the program is exported or imported. In the Variables tab, Task Builder or Task Writer, upper right side, the third tab variable, you can see the variable list and the system variable. You can monitor system variables and global variables in the variable list. By the way, local variables cannot be monitored. Let's take a look at the video to practice the creating and monitoring each variable. First of all, global variables is located in the top line of the program. You'll be able to create a normal variables and post variables. You can also create array variables if your software version is upper version 2.7. Normal variables can be set and stored in numeric, strings, and even float form. In addition, post variables in global variables must be saved in the task coordinate or joint coordinates. That means the format should be selected. So even at the same point, the joint coordinate is different from the task coordinates. So as described earlier, the type of values stored in joint coordinate is different from that in task coordinates. as you already knew, the task coordinate is available in move L and in all commands using task coordinate. Joint coordinate is available in all commands using joint coordinates, such as move J. The value is saved. After creating move J and move L, click the select variable. You can only see P2 saved as joint coordinate in the variable list. For move L, you can only see the P1 saved as task coordinate in the variable list. Understanding that each of the two coordinates has a different attribute, it will make it easier to understand how to teach the robot. For variables, when using if or repeat or the weight measurement function, etc., you can also select the variables that are already set. And then use them to update the variable for that value. The usability is so diverse that we will learn by programming later. Next, I will explain the variable monitoring function. First, let's create a local variable with define command. You create the one local variable or click the select variable icon for variable monitoring since the system variable is already set. Only system variable and global variables are available for variable types. Local variables are not available in variable monitoring because they are limited to relevant block. So when you select and apply variable value, system variable shows the value applied to the controller. And global variable shows the final value after program runs once. So you can monitor the variable while playing the program, so you can run it while checking the value in values monitoring if necessary. And the task writer provides the same type of skills. So as you can see, the global variable can be defined as more variable by adding global variable command in other command group. The reason why the variable are split is that the command can declare a total of 20 variables, 10 normal, and 10 pose variables. If you want to use more variables, you can do it by adding global variables. Also, you can input a command for each command. So you can use the same method to separate them according to the comments. So let me give you an example to open and declare the value for local variable in the subprogram below. Declare global before local variables. This is a variable declaration method of Python code. Please keep this in mind when you start the program. Where the video previous videos include this practice content. So let's move on the next slide. Another method of variable handling is to calculate variables using custom code. If you want to add 1 to variable after the first global count is declared 0, you can add a variable value with the Python grammar like global count equal global count plus 1 or global count plus equal 1. Also, you can change the numeric to a string to an integer, string to a float. The system count is created with 0 at first, and we will add one more system count in main sub. So let's see how to monitor the value of variables creating a new program. Try to use system variables. The system count created with 0 at first, as I already mentioned, and we will add one more to system count in main sub. So the system count plus equal 1 in the custom code, you have to input then just input the wait command 1 second and play. Of course, let's see. As you can see, to increase it by 1 per second, use a command called wait time. Go to select variable and system count for monitoring. You can see system count value 1. So it increased by 1, but since main sub value repetition is not set now, so try again. And system count increase over time, 1 by 1. The system variable has a value that remains after task stops, so you can see the value 13, and it starts from 13, increase successively. In the global variables, you can see there are no remaining value that they are reset. It starts from 0. With this practice, you can learn how to monitor the value of variable with a pop-up window. If you report to program manual, you can monitor values using a command called tp pop-up. And alternatively, you can declare a value arbitrarily with a value called user input. Let's watch the video to learn how to do this practice. So how to monitor a value with a pop-up window. Input a line from the custom code and select a single line. But you can insert a multiple line by a script file. Move to the edit mode. and global count plus equal 1 NTP pop up. As shown in the program manual, define the variables you want to monitor the NTP pop-up. After the format is set, the command variable called global count is marked 0 as is in the 0 order. If there are a lot of variables you want to monitor, you can branch into the ABC, etc. in the format and the monitor values of ABC by adding bracket 1, 2, 3, etc. The one set entire value can be viewed throughout the pop-up window. You can also add a value declare variables with user input. The variable can be selected in format including integer, float, and string and boolean. We select the value as an integer. Then select input pop-up message, then select the variable name, then input the message. So when you input a value through the pop-up message, you can see the next monitoring value is added by 1 from the input value. Next is conditional statement. Check if the signal has been received with the if command statement. Other cases can be monitored by dividing them into else, if, or else. The command you see here is the status of the robot to variable in string and reproduce the flow of the program in the main sub according to the string. In the task of this slide, the variable of global state is monitored by conditional statement. If the variable of global state is ready in string, the custom code command of the case that the variable of global state is main will be carried out. If the variable of global state is main in a string, the custom code command of the case that the variables of global state is initialized will be carried out. Next is repeat command. It is used to repeat a portion of task. For example, you can check if statement is repeatedly. If you select new variable, you can set variable and its value for beginning, end, and step in the repeater command. A typical method of using repeat function is to, of course, the repeat the command in the repeat and end repeat command block as many times as the variable value if count and the variable name is set. So the typical repeat function, so you can repeat the value as many value as possible when you name count and variables, count and variable name. And you can specify a conditional statement to run and finish only while the signal is received. If you select iteration statements and set it to true, you can carry out the repeat command infinitely. Next is continue command. It continues to work when a condition is detected within a conditional statement. In the task of this screen, when the digital input becomes on, the continue command in the line number 6 carried out and the flow control go back to the if statement in line number 5, which is the first line of the repeat and repeat block, ignoring moveJ command in the line number 8. Next is break and exit command. Break command terminates repeat command and moves on to the end repeat or below command. And exit command is the function that terminates the entire task program. In this case, you must play the program from the beginning. Next is sub and call sub command. Sub command makes a function to do something you want to process. It consists of the sub and end sub pairly, and we can write a program inside of the sub and sub block. Sub and end sub block should be located out of the main sub. Call sub command is to call the sub command that we created, which is located generally in the main sub block. We create a sub command named grep with a Dart platform and open a subroutine called grep in the call sub program. So if the program line is too long for the subprogram to be located, you can use the Go to Select Subroutine button to move the cursor to the subprogram that you are looking for. So we will use a set command to carry out a command called grep and subroutine. In the set command with the name of grep, we set the flange digital output 1 to on, output 2 to off. And copy and paste the set command block through the multi-selection function, and with the set command, set the flange digital output 1 to off and output 2 on. And then one program releases the grepper in a second after grep. We use wait command and play. It's right to proceed with the grepper open. The task writer has to manually customize the program that close, open, and stop the grepper. However, the sub call function binds the repetitive function. When declaring a sub command, it should be just main sub and main sub. Line number 12, as shown on the screen, is the same function as defined of Python language. And here are the thread features. The thread feature include the main program used by main sub and it runs the thread program used by thread at the same time. The program set in the slide has configured the program command to store information within the thread program. The program starts with the run thread and end with kill thread, line number 7. As we use sub command, we create the thread just beneath of end main sub. In thread, the motion command cannot be used. And you can record robot information by writing motion command in the middle. And also, you can export the robot information through the USB in Excel format. Here is an example how to set the USB path and the file name. The parameters to be called from the run thread will be set, the thread name, call thread, and repeat. If you run thread repeatedly, and you don't use to kill the maximum number of this thread, the maximum number of thread within the program is 4, and if not, then an error occurs when you run more than that repeatedly. And kill thread set the thread to shut down, terminate at that point. And I'll show you an example how to record data when you run the program. Now, this is an example, the result of recording data with the thread. Angle and angle speed is joined to 1 to 6, and you can see the date. And when terminating the thread using the kill thread command, you can see the execution name. You can select the thread to be terminated. And if the task itself is terminated, running thread is also automatically terminated. And you can use the wait command to wait for a short time. You can also use the wait command to wait for an input signal. So it also has the advantage of being able to AND or OR condition of each signal together. However, if you need to specify the program timeout, or if you cannot wait indefinitely for input signal, you need to specify timeout. In the case, you can use custom code. So please refer to the program manual. And the custom code is for using script programming. This option is used to create a single line, load an existing script file, or enter multiple lines as described earlier. And the variable declared in define command is a local variable that is available within sub or main sub block where it is declared in. So if you want to change the value of the variable declared in define command, you need to declare it as global by using custom code. And global variables will be also served as the local variable available within the subprogram block if it's a subprogram, and main sub block if it's a main sub. You can set output, speed, and end effector TCP reference coordinate at the set command. As I mentioned yesterday, you can find the set icon on the TCP pendant or dot platform, the home screen, the upper right side, you can see the set icon. And then you can define and you can choose select tool weight and TCP, etc. That set button is exactly same as set command. So I use this command for the output signal when I control the gripper. But it can also be used to override the whole thing by slowing the speed or so. And change the tool weight and change the tool center position, shape, and reference coordinate. In the case of tool weight measurement function, you can save the weight of the tool for external forces other than the weight of the tool currently installed to selected variable, which is already declared. The weight measure function is based on the gravity depending on the position of the robot, so the weight may depend on the position. Therefore, the weight should be measured in the same place as previous measurement. The pop-up command can also be used as a TP pop-up command and TP log command to be able to record the value of a variable. The pop-up command can also be used for debugging or monitoring. For example, if you use a pop-up command as TP pop-up command in if statement, you can check a flow of control to get into the if statement on debugging. And for pop-up message, this is same function as a TP pop-up command. So used to pop up simple message. So for comment, you can create an overall description of the program line. And next is understanding of compliance and force control. Compliance control is a function that responds to external forces like a spring when the force is applied to robot TCP. So with only motion control, the robot stops in the collision. However, with motion command and the compliance control, when there is a contact with the workpiece, it moves along the external force. So thereby a smooth process operation is available. And the following is how to set up the stiffness. So divide the stiffness by the distance unit of the external force, and then input the spring constant. So at the bottom there is a formula among the external force, stiffness, and distance. The external force is the multiple stiffness and distance. If you need to move the robot by 1 millimeter, when the stiffness is set to 1000, we need to external force of 1 Newton. And compliance command can be used with on, change. Change means changes stiffness, and off mode. So when you turn the compliance on and off, the robot will stop the program due to the joint torque sensor error if there is an external torque of 15 Newton meter or more. So therefore, robot should be run without external force when turned on the compliance. And the stiffness can be changed without external force. And the joint motions such as move J and move SJ cannot be carried out during compliance control, but task motion, linear motion can be performed because stiffness of compliance is set according to the task coordinates, such as X, Y, Z, RX, RY, RZ. So force control command is included in the compliance control command by default. Setup command turns the command control on for a certain time and turn it off. And default value stiffness 200 radian is 3000 Newton meter. The stiffness setting range is 0 to 20,000, 0 to 400. And there is the compliance function that runs smoothly as the value is getting lower. And just leave the direction Z and collision sensitivity 95% is too sensitive. The robot will enter into a protective stop when a collision value is detected. So force control and compliance control should be configured by setting up a separate specified area for each collision sensitivity to lower the collision, and it seems to be easier to set when the testing by getting lower the collision value in the robot limit. So once again, Run the compliance command. Finally saved. You can see the robot shows a motion that complies with the external force and returns to its original position like a spring when the force is removed. The following are the cautions when using compliance. Please take a look carefully. Those are very, very important to apply the compliance control. I'm going to summarize it briefly. The tool weight must be set precisely, and if there is an external force due to the incorrect tool weight, it will cause a continuous position error after turning the compliance on. And when you settle the dress pack, the external torque may occur on the robot due to its tension. So when installing the dress pack or other harness, please make sure to install it with the full extent. And if there is an external torque 15 Newton or more, the robot will stop the program due to the joint torque sensor error. So you can change its stiffness regardless of external torque. And you remember the async motion or blending motion is running, compliance on and off is not available. And after using stop motion command, you are recommended to use the compliance on and off. And after compliance on, only linear task motion is allowed, like a move J, like a move L. And a tool weight or TCP cannot be changed while compliance is turned on. And if you turn on the compliance and move, the robot may not be able to reach the target point precisely due to the torque generated while performing the motion. So therefore, turn on the compliance control near the target point, and after a certain number of operation, you have to do the mastering. So you can do this practice with the previous shown the video. So let's move to the next slide. Next is the force control. This function allows the robot to move toward a set force direction and maintain the constant force when it is contact with an object. So you can apply force while maintaining the reaction force only by making contact, but because of this, you can misunderstand the force command as the movement command, motion command. But this is a simple motion for applying force, not a command for precise position control. So we recommend to move the robot as close as possible to the target point, then use force control. And minimum setting value is 10 Newton. It is also possible to control motion toward different directions while pressing a certain force, so that you can use the collision motion application zone. And in singularity area, force control is not available because torque cannot be monitored in the singularity area. So for example, you straight the robot the fifth axis, the straight, and you push or pull the robot in the flange. In the teach pendant, you cannot monitor any force. Compliance command must be turned on to comply with the external force. And turn on the first command after turning on the compliance function. Force has one on and off by default, no change in function. And operate only with minus 10 Newton toward the direction Z. Set the target direction to the direction Z, and relative motion in the case if you want to exert the force in the relative direction, turn on the relative mode to remove the external force. So then you will use a force control. The setting time also sets up the time that takes up to the turn force control on. So for your better understanding, operate the robot to face downward. So let's apply a force of 10 Newton in the base minus direction. You will find the force when you look under anti-factor information and collision TCP. The robot will appear to stop when the force is detected. So when 0 Newton are detected, the robot will go down until it detects 10 Newton. So no force is detected. As you can see, the robot continues to go down. And by hand, when 10 Newton, about 1 kilo, is detected, the robot stops. And as you can see, a larger force is detected, the robot goes up and complies with the maintaining 10 Newton equilibrium. And the value of force control is set for each robot model. Yesterday we learned about the safety limit, how to adjust, modify the safety limit. In the case, in the category that you can find the force, and as you can see, upper right side at the bottom, according to the model, safety limit, force limit is different. And that was quite old, the M2.5 version. Currently is slightly changed, so please refer to the value according to your software version. And if you check the direction of force control, the force control will be operated toward the direction. And for directions that are not checked, the motion command is available. Of course, the multiple selection is available. And you can see the two graphs on the left When selecting multiple target direction, X and Z, robot moves like this, on the right. When reaching to the one target, then the rest continue moving until the target position is reached. And as described, if you turn on the relative mode, you can start force control with the value removed for the external force. So if you turn on the relative mode, actual force is set force only. In coordinate setting, since the coordinates are set base z plus, the robot moves toward from the base direction. So to move it toward from the tool direction, use the set command to change the coordinates. So when I mentioned about direction, the base direction was standard. So we use the set command to change the coordinates based to tool. So in the case, desired force, when you set minus 10 Newton, that means minus z direction from the base coordinate. But remove the minus because we already changed it to coordinate. Then you can see based on the tool z plus direction, robot moves toward. So let's say that the 10 Newton force is generated toward plus direction based on the tool z. And under this condition, when a greater force than 10 Newton is operated, you will see you already saw the robot moves backward. So it's simple practice. Please practice by yourself. And also a very important point to use the force control. Please read it very carefully. And for your information, a separate speed isn't available, and speed varies depending on the set force. So if it is a 10 Newton, the speed is generated as seen previously, but if it was a 30 Newton, it moves toward the direction that applies a force very faster, and minimum value can be set to 10 Newton and 5 Newton meter direction rotation Rx, Ry, Rz, and the maximum value that can be set follows the value of robot limits TCP robot force menu on the Workcell manager, the home screen, the robot setting. And the maximum force value is the maximum value that robot can be run. This is not recommended value, so if high values continue to be run, it may reduce the life of joints. So please set up as you consider the maximum torque value applied to the axis according to the position and tool be used. So for details, please consult with an application engineer. And the following is an example to detect the force. As previously shown, the set force is applied toward the set direction while the coordinates are changed through the set, and the compliance control and force control are turned on. So this program repeats the program until the same reaction is detected as a set force. Then it turns off the force, and compliance moves to the designated position. So enter input the repeat and the iteration statement to check for condition. Max 7 reference coordinate to tool coordinate. Grammar error. Axis Z you have to define. So as you can see, the force is detected, the robot moved backward. And you will find the speed difference. It becomes faster in 30 Newton compared to the 10 Newton. So when a set amount of force is detected, you can see it moves the set position. So it explains the sensitivity of force control based on the torque sensor, in which axis is significantly excellent. So let's have a 15-minute break and let's continue the training. Thank you. Let's continue the core training from Chapter 7, Modbus TCP Slave. The industrial communication is divided into field bus and industrial Ethernet. Field bus is a previous generation communication protocol implemented on a serial communication basis, and industrial Internet is an Ethernet-based communication protocol developed recently. Therefore, industrial Ethernet has more advantages than field bus in terms of speed and stability. On Modbus RTU, CAN Profibus based on the left, field bus protocol has been also actively underway, supported by Modbus TCP, Ethernet, and Profinet, which are based on the industrial Ethernet on the right. Modbus is a communication protocol for programmable logic controller PLC created by Modicon in 1979. It's simple, stable, and open protocol, so you can use it for free. So Modbus has a serial-based RTU and an Ethernet TCP based on TCP type. Modbus uses the master-slave communication method where slave server is the subject of data and master client read and write data from the slave. Doosan Robotics support RTU and TCP master function in the UI, and TCP slave functions are available through the custom code. In this training, we'll learn about the setting of Modbus TCP master slave. Modbus TCP master. TCP consists of the four types: discrete input, coil, input register, and holding register. However, the code that performs each function is divided into the 8 categories. The input signal is relatively simple, but for output signals, there are 3 types of digital analog signal: read, single write, and multiple write. So maximum 2 bytes, the size of data. The image shown in the screen is to set the IP address of the robot. You can modify the address in the setting menu. As mentioned earlier, the server is the entity that has data, and the client is the entity that requests the data. It is common to match the IP address of the equipment and robot intended to connect to each other. So the first 3 digit numbers it should be same, and the last 3 digit last number could be different. For last 3 digits you can set that differently. So hardware connection is industrial Ethernet-based communication. Ethernet cable is connected to LAN, not WAN port. So when you return to the UI screen and press the Add TCP Slave button on the Modbus tab in the setting menu, the disabled TCP type of equipment is created, and click the View button for detailed setup. Enter the IP address of the relative slave server device and click Add Signal. to input the signal type, address, and name. And simply enter a value and press the set button to confirm that the value is updated in input or output. The port number and advanced option maintain the default setting except in special circumstances. However, if the communication connection is not smooth, the signal leads with the notification changes to orange background. This is a display function of a connection fail. The set information is stored when the set button is pressed, even if the relative device is not connected. Store signal can be tested on the status Modbus test tab. And select type and slave are selected. The signal list is displayed. And you can perform the signal test and the monitor signal. So let me show an example. So before proceeding the Modbus setting, let me unlock the safety password. In setting menu, the network and Modbus, I created a TCP slave like this, and IP address should be different. Currently the robot has 100 last 3 digits. The IP address my laptop is 111 and port the default 502. And I add 2 signal, multiple coils, and multiple holding register. And for the test, I prepare the Modbus Slave, the program, simple test program. So connection, connect 111, and set definition, the slave ID 255, and coil, and slave 2, set up the holding register. And as you can see, Modbus master function is apparently good, and off. Let me check. You change it. And multiple holding analog. It's updated without any problem. So you can set the Modbus master like this. And precautions for using Modbus TCP. You cannot connect up to 5 slave devices and register 50 signals for each equipment. And the total number of the signal is 100 maximum, but from software version 2.8, the limit is bigger than before, so you can set the number of signals over the 100. Now let me introduce the Modbus Slave. By default, this slave function operates in the robot's background. Therefore, if the controller is normally booted, the connection error of master device will rarely occur. Mostly connection error occurs on stable hardware connection, IP settings, or misconfiguration of relative device. Because the register represents 2 bytes of data, it can read and write from 0 to 65, 535. In Slave, you can exclude code 02 and 04 from the function code used as the existing master function. And Modbus Slave table in the image can be downloaded from the Doosan Robotics website. The general purpose register area where data can be freely sent and received is numbered 108 through the 255. And except for event signatures, most monitoring data is updated in 100 ms units. Event signatures are updated temporarily, deter inputs of on and emergency. So as you can see, you can download the Modbus TCP Slave I/O table from the Robot Lab website. You can see the function code except 02 and 04 in error code is mentioned, and data mapping table. And you can refer to the below the information. And address holding register address, as you can see, general purpose 16-bit registers 128 to 255. And for example, 259 the robot state. And also you can monitor joint position, velocity, motor current, motor temperature. So I prepare Modbus 4 so connection 100. So the robot is a slave, and we send the data to my laptop and set up read and write definition. So I would like to check from the 259 holding register the quantity 50, the slave ID, and OK. And 259 is the robot state, currently standby, and if I push the emergency button, it changes 6. So emergency stop and release emergency stop, save off state, and server on, change it to 1 standby state. And as you can see, 270 joint position 1 to 6. The third and fifth axis rotated, and also 290 the joint motor current, and 300 joint motor temperature. So for your reference, the joint temperature 95 to the 55 is normal. So the following is an example of communication through the DRA command. And the command uses two types, set Modbus and get Modbus Slave. And next, pick and place. Here is a pick and place practice, and please try to create a task by yourself with Task Builder. I will show you the simple video how to create. So already set the electric gripper in advance, and go to Task Builder, select the electric gripper, and create a task called the pick and place. So you can select pick skill and place skill among the gripper skill. Pick and place. And choose picking pose and place pose for each command. And you can check the operation of gripper by selecting the extension for the Workcell item prior to pose setting. And it's advantageous to teach while the gripper's workpiece, the object is taken by holding the workpiece. And the pick button will allow teaching for the robust approach position first. And next, move the robot and save the place position in the center of the plate. And click the release. And enter the advanced options. And you can opt for a contact detection and also reduce the speed of approach. And turn on the contact sensing function of compliance control. The external force in contact is 10 Newton and the applied force is 15 Newton. And you can set the offset range after contact and the section to the detect contact. As you can see on the video, the workpiece, the height of workpiece is different, 3 different height. So the gap of the lowest and the highest one, we have to input so the gap is 10 millimeter. And there is an option to open the gripper before approach. I think that is a useful function. And then place. And let's play. So you can set a simple pick and place as seen on the screen. And pick and place practice with a task writer. As you can see, course of weight and course of gripper release and stop. There's a 2 soft gripper release and the 2 out signal on and off differently. So move to the position where you want to perform the gripper. And since it is advantageous to perform teaching while holding the gripper, hold the gripper and save the robot position. And previously the approach distance was calculated, but in this case, the approach distance is randomly added by 100. So add mobile and name it as approach. And Add the compliance control. On and off. And like a palletizing obligation training, always when you grip the workpiece, approach and pick pose and retract, and approach, place pose and retract. You have to set 3 times normally in the task writer. Of course, task builder includes or consists of all 3 movements in one skill. So approach, place pose, and set also place pose. And add compliance on and off. And I created the simple program with the palette skill. As you can see in the task builder, you can, if you select the palette in peripheral device, you can use the palette skills. As you can see in the command, here the feature skill, the palette 1 and palette 2. So here, please have a look at the video on the bottom right side. This is on position, and the pick palette, the place palette is the same as pick and place skills. And grasper release, you can check. And the advanced option, entry direction Z and upper distance and retract distance and upper speed, the retract speed, and compliance control also. Change the XY a little bit from the 3000 Newton meter. In this case, I use the same height of the workpiece, So no need to enter. And release gripper before picking. Enable. So same as place pallet. Wait a second, I remove. It's important to set the TCP correctly, and let's play. So of course, you can change the palette setting, palette pattern, row, column, and the coordinate. You can change. So do you have any question? Okay, so thank you for attending today's core training, and I hope that helps you a lot. And next week there will be a service training, and in 2 and 3 weeks there will be also industrial communication training, and end of October there will be the new application training understanding. So you can join by sending the application form. So thank you for attending core training once again. Have a nice weekend. Thank you.